All right, I want you to do something for me. If you're sitting at a desk or, have a laptop charger nearby, just grab the cable,
Hmm.
look near the end, right before the part that plugs into your computer. You see that little cylinder?
The lump?
Exactly, the lump. That plastic barrel that always gets snagged on the edge of the table. I've been looking at these things for, I don't know, 20 years.
Right.
And I gotta admit, for the longest time, I just assumed it was like a manufacturing thing. Maybe to stop the cable from bending too much.
A strain relief. That's a common guess.
Or just a weight to keep it from sliding off the desk.
It's funny you say that because that is what most people think, that it's structural.
Yeah.
But if you were to cut that plastic open, and please don't do that,
Yeah.
you'd find it had nothing to do with durability.
No, I know that now. I've done the reading for this. And what's wild is that this isn't just plastic. It's a functional electronic component.
A very important one.
And we're surrounded by them. Data cables, power cords. Yet nobody ever really talks about what they're actually doing.
Oh, they are definitely doing something. In fact, without that little lump, our whole digital life would be, well, a lot more chaotic. It's officially called a Ferrit bead.
A Ferrit bead.
And I think of it less as a component and more as a gatekeeper.
A gatekeeper. That implies there's something trying to get in or maybe get out.
Both, actually. It is fighting a constant invisible war against something that threatens every single device you own.
Okay, so let's unpack that because I think most of us figure you plug a cable in, power goes from A to B, and that's it.
It's so much messier than that. The enemy here has a name, EMI, electromagnetic interference.
Which is a very technical term. The research I saw called it wave trash.
Wave trash is perfect.
Yeah.
It's a fantastic description. See, to get why we need the bead, you have to understand the air around us. Every electronic device, your phone, your Wi-Fi, even your microwave, is switching currents on and off billions of times a second.
And all that switching creates noise.
It creates high-frequency energy.
Yeah.
And that energy doesn't just stay inside the device where it's supposed to. It leaks. It radiates out.
This is where I start to get a little skeptical, though. I mean, we live with this stuff. Is this interference really a problem for my laptop, or is this just engineers being paranoid?
Oh, you would absolutely notice. You just might not know what was causing the problem. The issue is that a cable, any long piece of wire, is basically an antenna.
Right. I remember that from physics class. If the length of the wire matches the wavelength of a signal, it just soaks it up.
Exactly. So your charging cable, unprotected, is doing two bad things at once.
Yeah.
First, it's a receiving antenna. It's picking up all that wave trash from the room, radio, Wi-Fi, noise from your fridge, and just funneling it right into your laptop.
And the second thing?
It's a transmitting antenna. Your laptop is a noisy machine on the inside. So the cable takes all that internal electronic noise and just broadcasts it into the room, jamming everything else.
Okay, so give me the worst case scenario. I go and I strip all the beads off my cables. What happens? My computer doesn't just explode, right?
No. No, nothing explodes. It's more subtle, which is almost worse. The symptoms are all over the place. Have you ever had your Wi-Fi just die for 10 seconds and then come back for no reason?
All the time.
That could easily be EMI from a nearby cable. Or on a monitor, you might see a flicker or some snow on the screen.
Oh, I've heard that hiss in speakers, too. When you put your phone too close to an old speaker and you get that buzzing sound.
That's the classic example of audible EMI, yeah.
Yeah.
But inside a computer, if that noise gets into your processor, it can flip a bit. A 0 becomes a 1.
And suddenly your file is corrupted, or you get the blue screen of death.
Exactly.
So the bead is basically an insurance policy against that digital chaos.
It's a filter. That's its whole job. Make sure the only thing flowing through that wire is what's supposed to be there.
Okay, so we've got the threat established. Now I want to get into the how. The physics here is really cool. It's called a ferrite bead. That implies iron, right?
It does. Ferrite is a ceramic. It's made by mixing iron oxide, which is basically rust, with other metals, things like manganese or zinc.
And they cook it.
They sinter at really high temperatures, yeah. And it creates this hard, brittle, magnetic ceramic.
But it's not just like a fridge magnet, right? It's doing something more specific.
Oh, way more specific. The key property is something called magnetic permeability.
Permeability. Break that down for me.
Think of it as how much a material likes to soak up a magnetic field. Ferrite has really high permeability. It just invites magnetic fields in. But, and this is the magic trick, it doesn't treat all of them the same way.
It discriminates.
It discriminates based on frequency. This is the whole mechanism. The signals you want, like the low-frequency power from the wall or your data, the ferrite bead just ignores them. It's invisible to them.
So it's like a clear window for the good stuff.
A perfect window. But the high-frequency signals, the wave trash, the EMI, They hit that ferrite,
Mm.
and the magnetic parts of the ceramic try to flip back and forth really, really fast to keep up.
But they can't.
It's too sluggish. It's too sluggish at those high speeds. And that struggle, that molecular friction, that creates what we call impedance, resistance. The bead becomes a wall, but only to the high-frequency signals.
Okay, I have to pause on this because this was the most surprising thing I learned. Energy can't be destroyed, right? So when the bead blocks the noise, where does that energy go?
That's the first law of thermodynamics right there. You can't destroy it, but you can transform it. And the ferrit bead takes that high-frequency electromagnetic energy and it converts it into heat.
Wait, so my charger cable is a tiny heater?
On a microscopic level, yes. It is literally burning off the noise.
That is so elegant. It just takes the problem and makes it disappear as heat. I'm assuming we're not talking about enough heat to, melt the plastic.
Oh, not even close. We're talking microwatts. You'd never feel it. But that's what's happening. The noise dies as heat.
The club bouncer analogy from the sources makes so much sense now.
That's a good one.
So the cable is the club entrance. The good signals, the power and data, they're the VIPs walking calmly.
Low frequency.
Right. And the ferrit bead is the bouncer. He sees the VIPs, he opens the rope, doesn't even give them a second look.
Zero impedance. Go right in.
Then you get the EMI, the troublemakers. They're not walking, they are sprinting, vibrating with energy.
High frequency.
And that's what the bouncer is trained to spot. He steps in front of anything moving that fast. He doesn't just block them. He kind of absorbs their energy, tires them out.
He converts their chaotic energy into a tiny bit of body heat, and they don't get into the club. It's perfect.
It really is. Now, we've just been talking about the lump on the outside of the cable, but these things are hiding inside our devices, too.
The lump is just the tip of the iceberg. If you open your laptop again, please don't. You would see hundreds of little black rectangles soldered right onto the motherboard.
And those are ferrit beads, too.
Surface mount ferrit beads. Same material, same principle, just a different shape. And on the inside, they have a few very specific jobs.
Right. The research mentioned 3 missions. We covered the first one, antenna suppression.
Yep, keeping noise from getting in or out.
What's mission 2?
Power cleaning. And this is arguably the most critical job for a modern computer.
Power cleaning. So the power starts out dirty.
Incredibly dirty. The power lines inside a computer are full of spikes and ripples. But your CPU needs perfectly clean, steady voltage. If the power jitters, the math goes wrong.
So the bead is like a water filter for electricity?
An excellent analogy. It lets the clean DC voltage flow through like water, but it catches all the grit, the high-frequency noise, before it gets to the processor.
Okay, and the third mission was vibration dampening, which sounded really weird to me.
Well, electronics can resonate. There's something called the piezoelectric effect, where electricity can make components physically vibrate. If a circuit starts to ring at its resonant frequency, it creates a feedback loop of noise.
Like a microphone squealing next to a speaker.
Exactly that idea. The ferrite bead changes the quality factor of the circuit. It deadens that ringing. It just absorbs the energy that would cause that oscillation.
It stops the circuit from basically humming itself to death.
That's a great way of putting it.
Listening to this, it sounds like the ferrite bead is the perfect component. It's cheap, it's passive, it protects everything.
You would think you would want them everywhere.
But, and this was a great plot twist, there's a whole group of people who actually hate them.
The audiophiles.
I was so surprised to find a controversy here. I mean, we're talking about high-end audio, guys like Paul McGowan from PS Audio. Why would people chasing perfect sound object to something that removes noise?
It all comes down to trade-offs. And it comes back to that word we used before, impedance.
The resistance.
Right. The bead works by adding resistance at high frequencies. In the digital world, we don't care about the shape of the signal. We just need the ones and zeros to arrive. But in analog audio, the shape of the signal is the sound.
So by adding impedance, you're changing the sound.
That's the argument. They claim that putting a ferrit bead on a speaker cable, for example, restricts the instantaneous flow of current. They'll use words like, the sound becomes squeezed, or lifeless. Think of a big sudden drum hit. That needs a huge instant rush of current. The argument is that the ferrit bead, acting as a choke, might smooth out that peak just enough to kill the impact.
So the bouncer's being a little too aggressive. He's stopping the troublemakers, but he's also stopping the life of the party from getting in.
That's the perfect way to put it. They would rather risk some radio frequency noise and use other methods to deal with it than accept what they hear as a loss of dynamic range.
And is that real physically, or is it more of a placebo effect?
The physics is real. Any added impedance will change a circuit's characteristics. Now, whether the human ear can actually perceive that difference, that's a debate that has raged for decades.
So for my laptop charger, stability is everything. For a $10,000 sound system, maybe purity is.
That's all about context. Reliability versus purity.
This whole deep dive just totally changes how I see my desk.
Right.
We are living in this dense, invisible soup of information. Wi-Fi, Bluetooth, 5G.
It's a miracle anything works at all, really. If you could see electromagnetic fields, you'd be blinded.
And the only reason our devices aren't just constantly screaming at each other is because of these little lumps of rust and ceramic silently burning off the extra noise.
It's a sobering thought, isn't it?
Yeah.
We focus on the smart tech, the AI, the screens, but none of it could survive without these dumb, passive bodyguards.
The silent guardian.
It really is. It needs no power, no software updates. It just sits there, obeying the laws of physics and keeping the peace.
I think that's my big takeaway. We're all obsessed with the cutting edge, but sometimes the most important tech is the stuff that's just quietly doing its job.
Absolutely.
So before we wrap up, here's a final thought for you to chew on. We just spent all this time on one visible component, this one lump. If this one simple thing is doing so much critical work, how many other microscopic, invisible parts are hiding inside your phone, working tirelessly to hold modern life together?
That is a very big question. The answer is probably in the thousands.
Maybe that's a topic for another deep dive. Thanks for listening, everyone. Go look at your cables with a bit more respect now.
Stay curious.
You know what I'm talking about, right? That weird little lump on your power cable? You've probably seen it a million times and never thought twice about it. Well, what if I told you it's actually one of the most important parts of your entire setup? Today, we're going to crack this mystery wide open. I mean, think about it. It's on your laptop charger, your printer cable. I've even seen them on USB cords. And it does nothing. No lights, no buttons. So what is it for? Is it just some weird, bulky piece of plastic? The answer might surprise you. It's a big fat no. The best way to think about this little cylinder is like a bodyguard. Yeah, a bodyguard for your electronics. It's a silent protector, standing guard against a threat you can't even see. Seriously, it's on the front lines of an invisible war. A war that's happening all around us, all the time. And the enemy in this war? It's something that could bring your entire digital life to a screeching halt.
Okay, so what is this invisible enemy? It actually has a name. Electromagnetic interference. You'll see it called EMI for short. And let me tell you, EMI is the secret villain behind some of the most frustrating tech glitches you've ever had.
So here's the deal. Every single electronic device you own, your phone, your laptop, your Wi-Fi router, is constantly putting out these invisible waves. And because our homes are just jam-packed with tech, it's getting super crowded in the airwaves. When the signals from one device start crashing into another, that's EMI. It's basically like all your electronics are in a room shouting over each other. Sound familiar? Have you ever had your Wi-Fi just drop for no reason at all? Or maybe you've heard that weird static hissing coming from your speakers. What about your computer screen flickering out of nowhere? If you're nodding your head right now, chances are you've been a victim of EMI without even knowing it. So the big question is, how do we stop this invisible chaos? Well, that is exactly where our mysterious little lump comes in. It's time to properly introduce the hero of our story. It's called a Ferrit bead. That's its official name. And its entire job, its whole reason for being, is to hunt down and eliminate that high-frequency electronic noise we've been talking about, the EMI. The name, ferrite bead, actually gives you a pretty big clue. Ferrite comes from ferrum, which is just the Latin word for iron. The bead is made out of this special kind of ceramic that's mixed with iron oxide. And it's this mix that gives it these really unique magnetic properties. Properties that make it the absolute perfect weapon to fight EMI. Okay, so how does this little thing actually work? The best way to picture it is to think of it like a bouncer at a nightclub, but for your data. It just stands there, right at the entrance to your device, deciding who gets in. This bouncer is really good at its job. It's super selective. See, the good signals, the actual power and data your device needs, they operate at a low frequency. The bouncer sees them coming, knows they're on the list, and just waves them right on through. But the junk signals, the EMI, they're the troublemakers. They show up as high-frequency waves. The ferrite bead spots them a mile away and boom, slams the door right in their face. You might be wondering, okay, so where does all that blocked energy go? It doesn't just disappear. Well, the ferrite bead is clever. It actually absorbs that chaotic energy and converts it into a tiny, tiny bit of heat. We're talking an amount so small you would never ever feel it. But it's just enough to safely get rid of that electronic noise for good.
But here is where it gets even more interesting. The ferrite bead's job doesn't just stop with that lump on your cable. Oh no. These little guys are like secret agents, hidden deep inside pretty much every piece of technology you own. They have a few different secret missions. First, on the cables, they put a chokehold on the wire to stop it from acting like a giant antenna, broadcasting or picking up noise. Second, if you look at a circuit board, you'll see tiny ones soldered right on. There, they act like a water filter for electricity, making sure sensitive computer chips get a clean, steady supply of power. And third, they can act like a tiny shock absorber, stopping certain circuits from creating their own interference. So it's pretty clear the ferrite bead is a hero, right? Case closed. Well, not so fast. It turns out that in one very specific corner of the tech world, our hero is actually considered the villain. I'm talking about the world of high-end audio. For audiophiles, the #1 goal is a perfectly pure audio signal. So, for someone like Paul McGowan from PS Audio, adding anything extra to the signal path, even our trusty ferrite bead, is a big no-no. They worry that it could actually constrict the sound and kind of choke the life right out of the music. So, you've got these two completely different worlds with two completely different goals. For like 99.9% of all our electronics, the main goal is just stable, reliable operation. And for that, the ferrite bead is absolutely essential. But in the high-end audio world, it's all about purity. Their goal is to minimize what's called impedance, which is basically just any kind of electrical resistance. And from their point of view, the bead is just another unnecessary barrier. But let's be real. Outside of that very specific niche debate, there is absolutely no question about it. The ferrite bead is a true unsung hero of our modern digital age.
I mean, it's a totally silent guardian. It's passive, which means it doesn't need any power to work, and it has 0 moving parts. It just does its job. And yet, without this simple little thing, our homes and offices would be a complete mess of chaotic electronic noise. The ferrite bead is one of the key little components that makes our connected world even possible.
So the next time you see that little lump, maybe give it a nod of respect. It's a tiny, brilliant piece of engineering that's working hard 24/7 to keep your digital life from falling apart. And it really makes you wonder, doesn't it? What other tiny, unseen components are out there, hiding in plain sight, just silently making our modern world work?